Hello and welcome to the Unit 3 Chapter 4 review. We're going to get started with number 1 right here, which has this following polynomial, and it's asking us whether k equals 4 is a 0 of that polynomial. They want us to use synthetic division. So, put a 4 on the outside, put 8, negative 26, negative 20, and negative 16 on the inside, and we perform our synthetic division as we normally would. And we get 32. Combine and we get 6. We combine and we get 24. We combine and we get 4. We combine and we get 16. And we have 0. So the answer to that question, number 1 is, yes, it is. Okay, number 2. Number 2 wants us to find all the solutions for the following polynomial. Well, the first thing we have to do is rewrite this polynomial in proper order. And I rewrite in descending exponential order. Then you want to get rid of this negative right here, otherwise you'll never have upper and lower bound for that. So I would get rid of that just as it's a good habit to have a leading coefficient be positive. So that means I'll make it 4x cubed minus 6x squared minus 34x minus 24 equals 0. Then they ask us for all the solutions. So for this one, we would continue as follows. We have all these numbers to try out. We can try a 4, see if that works. Okay, so let's try a 4. Try a 4 on the outside. So we have what? 4, negative 6, negative 34, negative 24. We drop a 4. We get 16, and we get 10, and we get 40, and we get 6, and we get 24, and we get 0. So one of our zeros for this polynomial is x equals 4. Now, with the remaining terms, since we have a trinomial to begin with, once we get 1 0, we're down to a quadratic, and we have the following quadratic equation: 4x squared plus 10x plus 6 equals 0. I probably want to factor out a 2. So we factor out a 2, and we're going to 2 times x squared plus 5x plus 3 equals 0. We can divide by 2 to simplify the numbers. Now try to factor this, but does not factor, so we have to use a quadratic formula. So we have negative 5 plus or minus the square root of 25 minus 4 times 2 times 3 all over 4. So that's going to give us negative 5 plus or minus 1 over 4, which gives us negative 1 and negative 3 over 2. So those are our 3 zeros to this problem are 4, negative 1, and negative 3 over 2. And those are our 3 answers for that one. Number 3. Number 3 asks us to find, using Descartes' rule of sign, find the number of possible real zeros for this one. Okay? What are the number of possible real zeros? Possible real zeros, where we look at the original equation and we have looking at sign changes. So we have 1, 2, that's a positive right there, that's a positive, and 3. So we have 3 possible positive real changes. So we have 3 there. And then it's also 1, don't forget 1, because we could have 2, we could have 3 is the maximum there could be, but there also could be 1 with 2 imaginary. But there are no negative real zeros, because if we put a negative x in here, we're going to get negative, 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 and negative. So there are no sign changes when I put a negative x in here. So that verifies that there are 0 negative real answers. But we could actually stop there because we know it's either 3 or 1. And therefore, we cannot have 2. We cannot have 2 real zeros because it's either imaginary or they're positive. Now, next one we have to do a little work here. It says use synthetic division to find the least upper and the greatest lower bounds guaranteed by the function. And so we have to do a little work there, and here we go. Now we want to write that in synthetic form, so we're going to have that as 1, negative 10, 29, and negative 20. And if we do that, let's say we try a number and see if it works. Okay. So we try to 1. If I try to 1, okay, and I put that in there, I'm going to get 1, I'm going to get negative 9, I'm going to get negative 9, I'm going to get 20, and I'm going to get 20. Oops. Alright, so actually I found a 0. So we actually know that x equals 1 is a 0. So remember that using the theorem, we know that all the list of possible roots have to be all the factors of negative 20, so it's going to be positive plus minus 1, 2, 3, 4, 3 doesn't go into 20. 1, 2, 4, 5, 10, and 20. So since 1 worked, we could have an answer below 1. So we can't try 0, so let's try negative 1. Yeah, because 0 obviously doesn't work when I plug in 0 into the original equation. That does not work at all. But if I plug in a negative 1, let's try that. Because since 1 worked, something below that could also work. It's not a lower bound. So let's try, the next one would be negative 1. So let's try negative 1 to see if that works. And if that works, be 1, that'd be what? Negative, we'll try negative 1, that's 1, so that's negative 11. That's, well, that's going to be 11. And it's going to be 40. And it's going to be negative 40, and that'll be negative 60. So we have alternating signs at the bottom here. So that means that negative 1 is our lower bound, and is the greatest lower bound that we could have, because we saw that 1 worked. So we go below it, 0 is not going to work, so therefore we went to 1. So in terms of integers, that's our lower bound. And if we continue to go from there, we are looking for our upper bound. Well, if we tried, let's say 10, because we have 10 or 20, right? So let's try 10 and see if that works. So we get 1, negative 10, 29, and negative 20. If we drop the 1, we're going to get a 1, and then we're going to get 10, what's that, 10? It's going to give to the 0, that's going to give us 0, it's going to be 29, and then we have 20, 10 times 29 is 290. So this does give us all positive, so 10 definitely works, but is it the lowest upper bound? That means it could be 9, 8, 7, 6, so that it is an upper bound, but it is the smallest upper bound. So we try 9 to see if that works. And if we did 9, we're going to see it's not going to work, because we're going to get a negative right there. See, it's not big enough to counteract that negative 10. So we know right there it's not going to work, because we need all either 0 or all positive or 0. So therefore 10 is our upper bound. So part C asks us to find all the solutions to this problem. They said this one was, well, find all the solutions. Well, we already had x equals 1, and since that worked right here, we already had our quadratic, which would have been x squared minus 9x plus 20 equals 0. So therefore we have x minus 4 and x minus 5 equals 0. So therefore our answers are 4 and 5 are our remaining two answers. So altogether our 3 zeros for this polynomial are 1, 4, and 5. There you go. Okay, the next one, number 4a, asks us to find the equation for the vertical asymptote. Well, we have to be careful to factor that first to see if that factors. And you can kind of cheat and see if 4x plus 3 works. And you'll see that x plus 1 does work with 4x plus 3. Because you get 4x squared plus, yes you do, it does work. So when you divide that out, you're left with x plus 1 in the numerator, so you have no vertical asymptote, so it's going to be none here. Okay. Now, horizontal or vertical asymptotes. You only have horizontal asymptotes when the powers are even or the denominator has a higher power. So there are no horizontal asymptotes. But for oblique asymptotes, the numerator has to have a higher power by 1. So we can divide out 4x plus 3 into 4x squared plus 7x plus 3. And it goes in x times 4x squared plus 3x. Subtract that, you get 4x plus 3, and that divides in 1 time. So your equation for your vertical asymptote is y equals x plus 1. In part C, they're asking us for 4 ordered pairs. Well, just choose really small numbers that go in very easily. So you might try something like 0, 1, 1, 2. You put in like -1, goes in 0, and then you get -2, -1. You get better at that by a lot of practice, but usually pick a pretty small number because you can be squaring it and multiplying it by 7, so pick a small number. This one asks us if a 6 plus 2i is a solution. Well, since it's a quadratic already, you can use the formula, and you get 10 plus or minus the square root of 100 minus 4 times 1 times 36 all over 2. So that's going to be 10 plus or minus. That's going to be -44 all over 2. So that's going to be 10 plus or minus 2i radical 11 over 2. And that's not going to equal 6 plus 2y. It's going to be 5 plus or minus I radical 11. So that's going to be no. That's not going to be 1. Okay, they want the vertical asymptotes, but this is already simplified. So it's simply going to be x equals 5 for the vertical asymptote. There's no oblique asymptote because the numerator does not have a higher power than the denominator by 1, so there's no oblique asymptote. Horizontal asymptote, the denominator has to have a higher power or equal, so as x goes to infinity, this becomes 1 over infinity, which becomes 0, so you're going to have y equals 0 as your horizontal asymptote, okay? And then your 4 ordered pairs, well, you could have something like 6, -1, 4, 1, just put any numbers you want in there, 7, -1/2, and 3, 1/2. I'll be accepting a lot of answers for those. Pick numbers right around 5. It's probably a smart thing to do. Okay, for number 7, they're asking us right here the equations for a vertical asymptote. We have to try to factor this first to see if we can find one. So you can take out a 3, and you're going to get 8x squared plus 6x plus 1. Take out a -3 down here, and you're going to get 2x plus 1. So just out of curiosity, I'm going to try 2x plus 1 up here to see if that simplifies, just as a check. Sometimes that works out like that. So if that's the case, that'll be, what's that going to be, 4x plus 1, and that'll give you 8x squared. Yes, that works. So try to simplify that. Oh, there was a -3 down here. Simplify that out, simplify that out, simplify that out. So I'm also going to get -1 times 4x plus 1. So you do not have an equation for horizontal asymptote. It's none right here. Okay, now equation for horizontal or oblique. Well, there is no horizontal because the numerator has a higher power than the denominator, so there is no equation for the horizontal. The oblique has one higher than that. And since we just divided that out, we already mathematically know it's going to be y equals, this is -1 here, so we should divide that in, and we get -6x minus 3 into 24x squared plus 18x plus 3. And you're going to get -4, 24x, that's 4x, sorry, 24x squared, and it's going to be plus 12x. That's going to be 6x plus 3. So divide that in, it's going to be -1. So it's going to be, well, we knew that already. So it's going to y equals -4x minus 1. Okay, we knew that already because we divided it out. We got -4x minus 1 already down here. But we had that already. For number 8 right here, we're looking for an equation for the vertical asymptote. Well, this is already simplified and factored, so you're simply going to get x equals -2 for a vertical asymptote. And for this one here, we have no oblique asymptote because the numerator is not bigger than the denominator, the degree. So therefore, as the denominator is bigger, denominator has a larger power or equal, it's vertical, so it's going to be 2 over infinity, which goes to 0. So you're going to say y equals 0. It's going to be our horizontal asymptote for this one.